Hello everyone, my name is Martin Schmidt and I will talk today about Minikube, how to get HCL connections in the smallest possible setup. Short introduction about Beck et al. Currently, Beck et al. Has 3 interest and focus groups. The first one is enable digital work. This is also where HCL Connections product is located in. Then the second one is from data to results, where we do data-driven decisions. And the third focus is on shape a flexible IT to get IT organizations, get it modernized. For the HCL Connections offering, we focus on 4 things. First of all, we are focusing on designing the infrastructure, helping you to set up connections and getting your infrastructure ready. Second one is to deploy HCL connections in your infrastructure, in the hybrid cloud, in the cloud environment, help you testing, help you migrating connections to the nearest release. Then we try to help you to utilize HCL connections better by doing some integrations, and the fourth focus is to operate HCL connections. If you don't have enough resources or knowledge, we could help you in this. Beck et al. Has 3 main locations. The basic part is in Munich. Then we have subsidiaries in Cluj, Romania, and in Florianópolis, Brazil. So to help you with support, we are distributed in Brazilian and in Europe, so we can more or less help you with 15 hours per day in supporting. And of course, we are partners of AWS, which is not relevant for this presentation, but for operating HCL's connections in the cloud, it helps a lot to be a partner of HCL. Our technology partners are not also AWS, but also HCL, Microsoft, and a lot of other major providers. Our customers are basic large international customers like the ones you can see here. And now I like to start with my presentation about Minikube, how to get it installed. So a little bit more about my person. So I'm a senior IT architect at Beck et al. And I'm doing IBM or HCL connections since 2007. So basically since HCL connections exists. I have strong experience in deployment and migration operations and customizations. And of course, my focus since the component pack is in place in HCL connections, I also focus on Kubernetes and container orchestration. I try to extend HCL connections by using customizations to programming some small extensions, and I focus on automated installations and to operate it with at least So today in this presentation, I will short introduction about the infrastructure. Short how I calculate the sizing to have the smallest machine possible. I talk some words about the product Minikube I'm using here. And then I'm going more detailed in the installation and configuration of the Minikube stuff and how to install all the component pack and the requirements to have component pack successfully running on Minikube. And in the end, I will show you some commands which might help you to manage the Elasticsearch index running on this installation. This might also be interesting for you if you don't want to use Minikube, but want to have more insights in what's going on Elasticsearch. So if you have a full-blown connection installation, which is, or want to have one, so you have the classic Websphere application software and the new component pack, and you want to have it a full redundant, then this presentation is not for you, because Minikube is based on to have a single server machine. So it's more of if you want to have a proof of concept infrastructure to just to have the functionality, show the functionality to a small number of users and do not require redundancy, high availability or other stuff, just to have it at least cost as possible. Of course, you need your user directory. You need a server for the classic WebSphere application server in standard with the database, the WebSphere, and you need one server to host the new component pack infrastructure. And this is the server I will mainly talk about in this presentation. To get this server in the right size, I did a small calculation based on the 6.5 documentation of HCL Connections component pack, where they listed all the sizings of the different pods. So in Kubernetes, you can specify the minimum required CPU and RAM and the maximum CPU and RAM the software will get from the Kubernetes. And as you can see here, usually when HCL Connections component pack installed, every of this software is running with 3 pods. So it has this it's run everything 3 times. To reduce the number of pods and the number of resources, I change this and say, I just run one of each of this. So I get the functionality, but I don't get the redundancy. I don't get the power, which has the 3 ones. And to have a limited number of users accessing it, I need at least the power and the resources to get the pod up and running. So I calculate use the requested CPU and RAM. So when you analytic servers, I need one run to run. So at least I need 0.5 numbers of CPU and 100 megabyte of RAM, and then calculate all this together. As you can see, I left over, I don't need this mail service. I don't want to have all this monitoring stuff. I don't want the Solar and Zookeeper because they are not required anymore when you use the type Elasticsearch for the type ahead search. And if you sum this up, you come to get everything to run that I want. You need 2.3 CPUs. And you need at least 7.1 megabytes of 7,000 megabytes of RAM. If you compare this to the AWS machine, you see that the smallest machine that can host this one will be an X large machine, which has 4 CPUs and 16 gigabytes of RAM. If you check to the HCL documentation, you will see that for a single node proof of concept, you require this machine, this type of machine. So in my case, you can run the software in 4 times slower, a smaller infrastructure. So what is Minikube and why I'm using Minikube? Minikube is a software to start a Kubernetes cluster in a real fast and simple way. It's intended to run it on a single machine, so not for a huge cluster, just for a single machine. and it has some minimal requirements. To get it up and running, you just download the Minikube command and run Minikube start, which will install Minikube on the local machine and provide all you with the stuff you need. You need some pre-requirements for it, like you need a Docker installed or some other hypervisor. Of course, I'm using Docker here because this is what I want for the HCL connections component. And of course, I need some disk space on the machine. So to install HCL component pack successfully in the sizing I just showed you, I choose a T3AX large machine, which is the cheapest one I can get in the sizing, with a 50 gigabyte hard drive attached to it. You can find more about Minikube here on this URL, which is the official documentation of Minikube. To get everything installed, I have here some commands to get it up and running. For historic reasons, I choose CentOS 7. It should also work on other Linux operating systems. There might be some more settings necessary. Some security settings might differ. But if you type in all these commands, you will have a Minikube up and running on a CentOS 7 machine. I provided a GitHub repository, and I have with this GitHub repository, I have an official blog, which I published. The link to this blog I publish in the end, where you can review and get more information about all the installation steps I'm showing here. Basically, to prepare your operating system, you install the base necessary updates and some tools, and you clone my GitHub repository to have some scripts available that give you the possibility to speed up and have easily configured all this stuff. To install HCL connections, you also need Helm, so you can simply just download Helm and get it running here. Of course, you need Docker in a specific version. I provided here an install script to download and configure Docker in the right version. And of course, I don't want to run every command as root. And therefore, I can use this command here as CentOS. The default user is CentOS. So I can grant the CentOS user, the current user, access to the Docker. If you execute this command, you must need to log off, log on to get it productive. But afterwards, you don't need sudo, but you could just run Docker version as a normal user, because with this command, you get the rights. Next step is to install Minikube, which is still download the executable, make it executable, and then run it as root. Here, the driver none means use the local Docker version and don't use another hypervisor. And of course, you can specify the required Kubernetes version. HCL Connections version 6.5 component pack says they want Kubernetes version 1.17.6. You could also even install newer versions of it and test it with this one. Or for component pack 7, you can also install it with versions 18, 19, whatever you need. Of course, you want to have Minikube started automatically. You can enter this one. And to make Minikube executable available to the current user, so you don't need sudo rights to execute it, you can use all these commands to copy over this stuff here. Minikube comes with their own kubectl command, which you have to execute with Minikube space minikubectl, then minus minus, and then the normal kubectl command options. To simplify this, you can add an alias to your configuration, say a kubectl. If you type in kubectl in the background, minikube kubectl minus minus is execute. So if you then type in kubectl get nodes, it will run, and you don't have to type in minikube kubectl minus minus get nodes. After this, you have the basic infrastructure running. You have the Kubernetes cluster running. As a next step, you need to initialize Helm. Helm is the package manager, which is used to deploy easily the scripts that are provided by HCL connections. You can simply create the normal access groups for Helm, and then you just simply can init here. And this service account tiller is configured with this command before. Then, of course, you need a Docker registry where you can upload all the images provided by HCL. You could use an official Docker registry, which a private official Docker registry are like in AWS ECR, or you could provide and run a Docker registry on your Kubernetes cluster. These commands here help you to set it up and run it on your just Minikube Kubernetes cluster to have your own Docker registry. At the end, if you execute it like this one, you have it at the end, you can access it here in the local name of your host and the Docker port. The important thing is that the Docker registry will fail, or you have to do more configuration if you don't trust the certificate of the Docker registry. So per default, it's some strange self-signed or non things. And now with this command here, I will put in some certificates into the registry, and also here with this commands, I trust the self-signed certificate on the machine. So Docker will communicate with this Docker registry without complaining. The next one is configure and get create and install settings sh command with a lot or with some environment variables. You will see this concept in a lot of scripts I'm creating or created by me to simplify make some settings available. For larger installations, I create this install settings sh with a different program to make it customizable. But for you, just here, you could create it like this one here. The install version here has some effect in how the other the sub commands are executed, because the installation differs slightly between the 6.0 component pack and the 6.5 component pack. Here, for instance, I can specify the namespace to be used in this one. And important for this Minikube here is you can specify the CNX size as small, means I configure it that only one pod is running. If you omit this command, every pod will run in 3 times. Minikube has a standard, uses standard as storage class. So if you say, I want a new storage, use standard. It depends on your installation of Kubernetes, what you have to enter here. You could configure it as using a standalone Elasticsearch, and I don't want to use the Zookeeper and Solar. And of course, I need the Docker registry information, and I need the component pack infrastructure here. This, of course, depends on the settings on the Websphere infrastructure. I kept it here in the default values, but you have to adapt this to your setup of the classical Websphere infrastructure, which will run on a different host. When you have configured and installed, created this install settings and adapted to your needs, you can simply start with installing the component pack onto this Minikube. Of course, you need the component pack installation file from HCL Connections. You have to be a partner, or you have to be in FlexNet. You can download this stuff from FlexNet if you have a suitable account. And you need to unzip it. In the commands, I always expect that it's extracted to the root account, so you don't have to add some strange paths to it. And then, of course, you can this install settings here. I'm loading it just in the operating system. This is .space, which means that this environment, for instance, the CNXNS is available in the normal operating system, bash commands, and so on. You can use it here. Then I use here a script which will create a configuration file for my Helm commands. When you usually check the installation instructions from HCL connections, they always use some --set parameter, --set different parameter installation settings when you install or execute the Helm charts. The more easy way is to put everything in a file and just specify this file using your Helm commands. As you can see below, this write cp config script will create an install cp YAML file, which is based on this install settings at the beginning. The advantage here is you can check what's in here. You could add some more parameters. You can, if you rerun this command, you see what you already set, and it's much easier to get this executed. So after this one, I created this file. Then, of course, I create the namespace, here the $CNX namespace. So I take the variable which I configured here in this install settings. The namespace is not only necessary here, but it's also in the Helm commands. It's necessary here. It's necessary here. And also, if you change the namespace from connections to something different, you need to, in every Helm command, it is necessary in the variable. So it's also configured in this install CP. So basically, with this command connections volumes, I create the persistent volumes for the necessary components that I will run on the Kubernetes and the Minikube Kubernetes. This will basically so HCL provided this script somewhere, but it was not sufficient to use this auto AFS enrollment, auto storage enrollment. And therefore I adapted it here and made it available in my Git repository. Then, of course, you need to upload all the images from HCL, which are provided here in the component package into your Docker registry, which is the ECR registry, is also the local registry, which is configured in this install settings. So, and the local install Docker registry has no username and password. Therefore, but you have this command requires some. So this is the reason why I just specify dummy. If you have some Docker registry which requires authentication, of course, you have to specify more. Docker will take the component packs, enrich it, and first create the Docker images on your local machine. And when they are finished, it will upload it to the Docker registry on the Minikube. Therefore, after this process, you can get rid of all local images on the machine, which basically is get here all images IDs locally on the machine and then remove it. There's one for the sanity images. They will not work because two images depend on each other. So you can force the deletion just by this one. On Minikube, you will see that there will be some other local images which Docker complained that are still in use. These are done by Minikube and it's okay. Just keep it. But with this, you can save about 20 gigabytes of local disk space, which is not necessary anymore because all your Docker images are already now uploaded in the registry and provided for further use by the command. When you're done at this stage, you can go to the standard installation instructions of Kubernetes, of your HCL component pack, which will easily is the same commands. What I did here is the Microsoft services, connections, hybrid cloud, Helm builds are all this Helm builds, Helm instructions, which are downloaded in this component pack. When you go from version to version and you try to record how and want to simplify the commands, all these names here change with version names. So it's quite hard to have some easy installation instruction. And therefore I use this one here to add the Helm chart, and with this command the current version is automatically added here. And then in this Helm chart you get the absolute path with the current release information into this environment variable. And then you could just upgrade the first is the bootstrap process. It requires the Helm chart here, which is calculated here automatically. The -e means if it's not exists, install it. And then here I use my install cp YAML file, which was created earlier. I don't use this --z commands like in the HCL configuration. I just use here my install file. And of course, I have to specify here my namespace. And yes, by default, you type in connections, but if you change it for some reasons, so you always have to change it. So I use the variable for it. Basically, when you go to the documentation, you see you need the bootstrapping. Then you have to create the connections environment, the infrastructure, install Elasticsearch, RNUG. Then also the customizer is installed, the ingress controller. Optional, you can install Activities Plus. In my sizing, Activities Plus was not taken into account. So basically, if you want to have it, you might need a larger machine because every Activities Plus was not calculated into it. As you can see, beside the documentation of HCL connections, where you have to specify all the set command, set environment or set variable, it's quite handy with this one here. Every command is just a two-liner. Don't think about all the stuff, what you need to customize and set here, because it was already set here in the install CP. You can review this one. If you want to have more information in it, you need to change some other variables. You also could add and extend this one here. The most important for this setting here in the Minikube environment is that the setting of replica count for every these features is set to 1 here. You could also do this by using --z, but it's easier in this file. Usually you can downsize the installations easily, but for the MongoDB it works, but for the Elasticsearch, when you started installing it with a 3-node cluster, so you have 3 types times the Elasticsearch client, 3 times the Elasticsearch data, and 3 times the Elasticsearch master, it's not that easy to downsize it again to 1, because the Elasticsearch master says, oh, I'm a master with 3 nodes. So there has a quorum of at least 2 master need to be available to say, yes, I'm the right master. So if you downsize it to 1, the master says, oh, there were 3 masters running. Now there are only 1. I'm not the master because I'm the one who's left over. I don't see each other. I'm not the master. You have to take some Elasticsearch commands to tell this single master to be, yes, you are the only master. So it's much easier not to power up 3 ones and then downsize it to 1, but just to start it just once, though the single master says, oh yes, I'm the only master, I operate as master. So this is the reason why it's important to have this replica count set initially in the install CP YAML or in the set configuration. After this, you have all the pods, all the infrastructure running on the component pack side. When you go to the customizer configuration, of course, you need this ingress or this reverse proxy running in front so that the traffic can be distributed between the customizer traffic and the normal traffic that goes to the backend infrastructure. In a large infrastructure or on AWS or so, you probably have a load balancer in front which can do this traffic split. In a Minikube environment, you don't have a load balancer functionality. And Minikube or Kubernetes itself cannot listen to port 80 or port 443 per default. Of course, you can force it to do so, but I think it's much simpler to have an Nginx web server running on the same Minikube server. It does not take much resources and it's easily to install and configured. So basically it's the same setup that HCL recommends, but not a separate server, just on the single one. To get the Nginx running, it's simple, just by installing it and to enable it. SE Linux you have to enable this forwarding, otherwise the local HTTP request will not move to the Minikube. And of course, you can create an SSL certificate, or you have to create an SSL certificate, or you purchase one, or you use the certbot tool to download it from the automatic stuff here. So it's up to you. I just showed here a simple method here. And of course, you have to adapt your Nginx configuration according to the documentation of HCL. So here you can then forward this traffic and so on. In the configuration, it says you need some proxy path URL. Just you could use here, this is the control pan, though this is the endpoint of your local Minikube Kubernetes cluster, and the 3031 port, this is the port of the HeyA proxy, which is the main component that will do the customizing stuff here. Of course, the next step is then the integration between the Websphere components, the classic Websphere component, the component pack. You need to configure Websphere to forward all this traffic to your component pack. You need to configure the component pack to load all the profile informations by the profile data migration port and so on. This is identical to every other installation, so I don't show it here in detail. Just here, go to this documentation and follow these instructions. When you have done this, you should be able to see connections with component pack in this for about 5 to up to 10 users. I never did more than 2 concurrent user sessions on this setup. I'm sure it will host a little bit more, but as we already sized it, if we really power the users, pods will start to fail because the infrastructure is not large enough to have all the pods growing to the maximum limit of its. So if you really stress the infrastructure, pods will start to fail and so on. So it's just for a limited number of users. One interesting stuff I want to show here is the Elasticsearch components. At the beginning, I was searching for how can I see the indices in Elasticsearch? What is going on in Elasticsearch? Oh, I see they are getting the indices are showing yellow, which means they are not replicating. Of course, we have a single instance here, they cannot replicate. And I failed to find an easy, simple Elasticsearch user interface. And therefore, I digged into it and found that it can be easily managed by simple HTTP requests. And for the built-in Elasticsearch, you need to get the certificates and then use the certificates out of the Minikube or the Kubernetes configuration, and then use these certificates in each HTTP request. And to simplify everything, I put in here this Elasticsearch commands into my Git repository. and I created command meets get certs, that's at H, which just extracts the certificates from the Kubernetes installation and places them locally and makes them available to the curl command. And then you could easily use this esget command. And here you see with executing this command, you just see all available indices on the Elasticsearch cluster. And then, of course, we have a non-one node cluster, but per default, all indices are said, please have one replica. They are all orange. And to have them green, you must say this index has no replica, just the master index and no replica. And with this command, simply you can say ASPut, which is a put command, say this cluster, I want to change the cluster here of this index, and then I provided a JSON file to say, so this is the data I put, and say just get rid and change it to no replica. And after executing this command, the index RNUG collection will show you as green because it has one master index, no replica, which is fine for a single node installation. Of course, you can use this command with all other indices as well. There will be some indices for the type ahead search, for the matrix components. You will see a lot of things. If you want see more commands, what you can do and have more ideas, I have in this Git repository, you see some more commands I put in here, but of course you can just search for the API documentation and extend whatever you need. And as the last one slide here, I want to just show you the Kubernetes dashboard, which Minikube, you could simply add this dashboard as a command, and then you could start this proxy command. And from the proxy command, you can access with a browser on the machine this URL, and then you get the Kubernetes dashboard. Here's some information from the current node. And as you can see here, when you got just update it, it has here the requested. It's only request currently 3 CPUs, and the limit would be 20 CPUs. So if you really stress it, some pods will fail because our machine just has 4 CPUs. But here, as the limit is, or the requests are 3 CPUs, Kubernetes will start up all of the infrastructure. The same is for the RAM. All the pods, when you start up, they request 7 GB of RAM. This is the one of what I calculated at the beginning. And you see the machine has 16 GB, so it's sufficient. Of course, when you stress everything, they could blow up until to 23 GB, which is more than the current machine has. So it will then stop pods will failing because Kubernetes will kill when they are will kill pods if they use too much RAM. Of course, if you want to have some more information, go to this documentation, the internet. Basically, the first one is the blog post based on my GitHub repository. We can have a little bit more instructions what it does. It also contains some installations to get it in AWS native or in a full clustered environment. I will have tomorrow a session about getting HCL Connections component pack in AWS native. And of course, the installation instructions by HCL to get the integration between the classic Websphere infrastructure and all the new component pack infrastructure. So thank you for your listening. If you have now further questions, I'm here to answer it. I think I still have 10 minutes to answer possible questions.
Мартин, спасибо огромное за презентацию. Я пока не вижу вопросов от пользователей.
Martin, thank you so much for your great presentation. I do not yet see any questions from the audience.
Если ребята сейчас что-то еще напишут, я продублирую их вам на e-mail.
If we receive any questions, I will send them to your email.
Thank you.
Спасибо.